So the end of our lecture portion, there will be more topic videos, is what to do this week. So obviously you'll watch all of these, but let's take a look and see what it says. It says here for design 330, we're working on gear set design for a gearbox for a pump. And we'll be talking about that more as we go. But we're just going to start off doing some good old drawing. So watch the videos that we were just looking at a moment ago. The lecture videos are almost done here, and I will be doing specific topic videos to help you know how to do these. And once you've done that, you've got drawing files and design files for this week. Okay? And the list of files are on this spreadsheet. So you're going to fill out all this data for 1, 2, 3, 4, 5, 6 gear sets. That really won't take too long. You just do it in Inventor and show me the data that you've got. That you don't even have to save the file because you're going to give me the data that comes from those files here. Okay, but then we're all going to take this number 2 set of data and we're going to make some. Let's see what those drawings are. You're going to do something called the gear set data drawing for gear set number 2. You're going to take this gear set and you're going to make a very specific looking drawing in Inventor. Let's see what that drawing looks like. That's what it looks like. So you'll use Inventor. You don't need all this internal stuff. You just need what you see here. The pinion data, the driven gear data, the nominal center distance with a set of tolerance. Something that says pinion drive hex socket and driven output hex socket. You don't need all these little things. You just need the 2 views and point. And then you'll want to say what the gear set ratio is, which is input number of turns by output turns. So this one is 4 turns of the input gets you 1 as an example. And then you'll write the data in. There's a revision history, new release. This is a B-size drawing. This should probably say gear set 2, sorry. Gear set data sheet, spur gear, and give the ratio. Okay, and this is a ANSI A. So that, you can pop that together. I think you're pretty good at that quickly in Inventor. Then I want you to reproduce that in AutoCAD. Take that data and reproduce those. Now, I have to give you, I'll give you what it looks like, but basically, instead of all these little gear teeth, you just draw the outside diameter, the root diameter as the outside diameter as an object line, the root diameter as a hidden line, and the pitch diameter as a center line. So that's how you do in AutoCAD. Those and do those up. And then you're going to do a pinion gear drawing. And again, you're not going to have, actually you will have all this. I'll give you the file to make this pinion gear from. I have to give you the file. I have a gear, and you're going to just reproduce this drawing in Inventor. And then again, you'll do the same thing. You'll reproduce it in AutoCAD. And I'll be talking about what these all mean and how to do those in the lab, in my lab demos. So I'll demo this in lab, but you might be able to get started and get going. So you'll do the pinion drawing and put that into AutoCAD. And then you'll do the same thing for the gear drawing, the driven gear drawing. And I have those files for you. Okay? But they'll all follow, as an example, your two gear drawings have a face view, a section view, isometric. There's some gear data, and then the call outs are as you see here. And we'll go over that in more detail. Okay, I expect that's 1, 2, 3, 4, 5, 6 drawings. I expect about 6 hours worth of work, maybe a little bit less, those drawings. So that's not too bad. And you've got an hour or two of watching things. You should be spending 9 to 15 hours a week on this class. Okay, there's 6 hours of quote in-class work and 3 to 9 hours outside of class. So this is a fairly heavy duty stuff, but these are just drawings. And I've given you samples, and I will give you the inventor files. Once you've got those done, we have a little activity here to do. I want you to review this and tell me what's wrong. What's wrong with this image? And so gear design does take some thought. This is all over the web. You see this over and over and over again. And so you can take a look at that. And then here's what you do. Post a reply in the discussion. Okay. As you know, I prefer the replies to be a video, so you could maybe do a little work. So draw on the image. Maybe put it into Paint, or put it into a Jamboard. However you want to do that, be able to draw on the image and then explain what the results of your drawing are. So where each gear will go. So this one, if this gear turns clockwise, show me which way each of these gears will go and explain what those results mean. And then I want you to go online and do some research. This is why you're supposed to have taken Design 300 or something that shows you how to find design resources. Find a gear handbook that you might be able to give to this artist so that they can learn about gears. Of course, it's really for you to learn about gears. I'll give you some hints. There's the Boston Gear catalog, the Martin Sprocket catalog. There's probably a bunch of others. Engineering, you could even look at the engineering toolbox.com. There's a bunch that you could do. I might even look at some ASTM or ASME publications, find some. But you have to be able to get into it and look at it and find out, because you have to give a short description of the type of gear design information that is included in that handbook. Okay, so that's your discussion. That might take half an hour to an hour also. When you're done with that, we'll be working on your executive summary. Let me go to the top of it. So this is all much as you know. You've got your images that are very quick visual summary. Make this green. Schedule your hours at the beginning of the week. Let me know what you actually did and how much time you did actually for each one of the slides. Okay, and then let me know again, did you watch the lecture videos? Did you watch the playlist? Did you do the assigned activities? And then did you get your summary done? Did you get all of your drawings, some or none, done? And did you go to a live web meeting? So on this one, you'll have some gear set data drawings. There will be 2. And it's best to annotate it so that I know what you're showing me. Know that you've done a gear set drawing and maybe where you got it and how you came up with it. So make that a good annotated thing. Pinion gear drawings, there's 2 of them. Same thing. And you put your drawings in here. Oops, this should say driven gear. Says driven gear up here. And then we have our gear calculations, which is show me that you understand what that big fancy, I think I closed it, that big fancy inventor thing was. Okay, so let me know that you know how to do that. Yeah. And then put your spreadsheet. Oh, there's your gear nomenclature. I want to know that you understand the design features of a gear. And design standards. You know that you can find industry standards. So let's take a look. What are you going to submit? A PDF of this executive summary. Okay, and you submit it to the Canvas site for the course. This is your self-certification. We didn't have this last week, but this lets me know that it is all of your own work. And I know things can get hefty. You don't get things done. Feels like there's pressure to get it all done because you get full credit for doing all of it, blah, blah, blah. No, I want to see only the work that you did and that's representative of your skill. If I were to ask you to reproduce that for me, you better be able to do it, your ability, and the available time you have. Some of our students have less time than others, and I understand that. Okay, and what you do should be representative of that. And then let me know of your working conditions. Okay, and you have to edit this. So, and I think I went over that a little bit before, but technology and access to software was or was not. Only one of those counts. So if it was a difficulty, you have to get rid of was not. If it was not a difficulty, you have to get rid of was. I want these to be complete, true sentences that make sense. Okay, so you'll go through those. This is your grading. We work on the scope. Okay, the breadth is everything covered. You have something for everything. The depth are all of them detailed appropriately. So you may have it all in there, but maybe some of it is not fully fleshed out and done. So you can get full, half, or no credit for that. Application. Does it demonstrate the proper application of technique? You know, are you using Inventor properly? Are you using spreadsheets properly? Are you scaling things properly? Are you using the tools according to good design and drawing skills? And then is this visual presentation and the presentation of your drawings done well? So you can get full credit of 2.5 for each of these, as little as none. So that's 1, 2, 3, 4 times 2.5. That's 10. Okay, so that's your executive summary. Put it in Canvas. I think I have to change this so that you goes. Nope, there it is. It goes to Canvas. All right, so you can go to Canvas there. And you've got your, let me make sure that was the one. Yep, week 2, executive summary. And then each of your drawing files. So you've got a lot of drawing files to put in there now. You'll put all your drawing files into here. And again, this is worth 10 points. Okay, so if I can get to them, you get full credit. If some are missing, okay, or your links are not correct, make sure that I can get to them. Make sure. Okay, so this is an additional 10 points. Okay, so there we go. That is what to do this week, and I'll look forward to seeing you in lab or in an appointment. If you have questions, I suspect you will. We'll be posting more videos and more links as we go, but this should be good to get you started. So there we go. I look forward to working with you in week